Welcome to Westel's Passive Components for Inquiring Minds. In this episode, we will discuss diplexers and duplexers. Duplexers and diplexers are often confused due to their similar names and their roles in managing frequency bands. However, they serve distinct purposes. Let's begin with the basics of radio transmissions. One common method of radio communication is frequency division duplexing, FDD, which utilizes two separate frequency bands for each direction of communication. For example, in public safety networks, the 800 MHz band is frequently used. The tower's outgoing signals, known as downlink, typically range from 851 to 861 MHz, while signals sent from a portable device to the tower, known as uplink, usually operate within 806 to 816 MHz. In addition to the 800 MHz band, public safety networks can operate in the VHF and UHF bands. VHF ranges from 150 to 174 MHz, while UHF covers 450 to 512 MHz. Now, with that background established, we can identify the differences between a duplexer and a diplexer. A duplexer merges or separates downlink and uplink signals within a single frequency band using bandpass or notch filters. It effectively isolates uplink and downlink bands from each other. A duplexer can receive the entire 800 MHz band on a single input and then split the signals into two outputs, one for the downlink band and the other for the uplink band. Conversely, it can also accept separate uplink and downlink bands to generate combined uplink and downlink outputs. A diplexer, on the other hand, either combines or separates two different frequency bands using low-pass, high-pass, or bandpass filters. It isolates distinct frequency bands from each other. For example, a diplexer with two inputs, one for UHF and another for 800 MHz, can combine these into a single output. When the process is reversed, it can take in combined signals from UHF and 800 MHz and separate them into separate outputs. Each band's output includes both its uplink and downlink bands. While diplexers handle two bands, there are also triplexers for three bands, quadplexers for four, and so on. Due to this confusing terminology, these devices are often collectively referred to as crossband couplers. From now on, we will use the term crossband couplers to refer to devices that handle any number of bands, such as diplexers, triplexers, or quadplexers. Duplexers are commonly used so that a single antenna can serve both uplink and downlink. Inside a typical transceiver, a high-power amplifier is used for transmitting, while a low-noise amplifier, LNA, is utilized for receiving. If these were connected directly to a single antenna, the high-power amplifier would overdrive the LNA, causing significant issues. However, when connected via a duplexer, the duplexer blocks the power from the high-power amplifier's frequency, thereby protecting the LNA. Often, base stations have a duplexed output, making them ideal for direct connections to an antenna. However, when connecting to a distributed antenna system, DAS, separate uplink and downlink inputs are often required. A duplexer is employed for this purpose. Additionally, both the downlink signal into the DAS and the uplink signal out of the DAS may need to be power optimized independently. Therefore, variable attenuators are added to each output, allowing for individual power control in each communication direction. This setup is known as a DAS signal conditioner, DAS tray, or point of interface. In another episode of Passive Components for Inquiring Minds, we discussed how an equal power divider was used to combine a UHF and an 800 MHz signal source, and noted that there are more effective devices for this task. A crossband coupler is one such device, as it can handle higher power levels with less loss compared to an equal power divider. Crossband couplers are particularly popular in the cellular industry, where multiple bands need to be combined to share a single coaxial cable, or where the output of an antenna must be split into separate bands for different base stations. The loss from duplexers and crossband couplers is typically less than that of power dividers because they just separate signals rather than splitting them. Now you should understand how duplexers and crossband couplers work and their respective applications.